All right, I still have to print this off for you, but I've been trying to lay out the rest of the semester, just so you know. So this past Monday, we did the pretest. All right, yesterday was the test, so today I'm going to lecture on Chapter 5. You're going to have work to do, homework and labs like we've been doing for Chapter 5, for Chapter 6, and for Chapter 7. Notice when they're due. All right, they will be due 2 weeks from Friday. That should give you plenty of time, and I've built in a lot of lab time for this too. Tomorrow, as it says, we'll go over Chapter 6. So today is on debugging, and again, it's a really, really short chapter. All right, tomorrow we're going to go over the DOM, which is, in my opinion, probably the hardest chapter in the book. All right, Friday we'll go over Chapter 7, and that's on images and some other stuff with JavaScript. But on Friday, I also have to pass this out. Yeah, technically, you have a midterm in here. And for that midterm, you're going to take an existing website and rewrite it. And if you say, I don't know what that means, you'll get it passed out on Friday. All right? And again, it's not going to be due, notice, until December. That said, please don't do this. I had a guy, he ended up becoming a very good friend of mine after he graduated, Randy Kirsten. And Randy, I'll always remember this. He came in the Monday after Thanksgiving, and he said, well, thanks a lot for screwing up my Thanksgiving. And I said, I have no idea what you're talking about. He goes, well, that assignment that's due today was like a midterm type of thing. And I said, yeah. He goes, why? I've spent all weekend working on it. I said, I assigned it the first day you came into class in September. Is it my fault that you waited until this weekend to start it? Well, I guess not. Okay. So the point is, even though it'll be passed out on 10/8 and it's not due till 12/3, almost 2 months, the kind of thing when you get a few minutes of free time that you want to think about working on. All right, so that'll be the rest of this week. And then notice next week, lab all period on Monday, lab all period on Tuesday. Wednesday we will have another one of these pre-tests, and a lot of it will just be taking the test that the pre-test you just did and rewriting it, making it more DOM friendly. If you don't know what that means, that's what tomorrow's lecture is about. And then a week from tomorrow will be your test on Chapters 5, 6, and 7. And then notice lab all period. That's enough to go through for right now, because that gets you through the rest of this week and all of next week. All right? Now, just so you know, you may care about this, you may not care. And either way, that's just fine. Where am I here? I sent you 2 emails this morning. The first one down here had a bunch of URLs that if you're interested, these are anywhere from 5 minutes long to 20 minutes long, but there are a bunch of different presentations on how you can debug using either Visual Studio Code or Chrome Developer Tools, or both of them together. All right, I'm not going to go through any of them. I just provided those out there that if you're interested. You'll notice 2 of them are by a guy named James Quick. All right, he does a lot of videos and stuff like this. All right, and I tend to look at it, and if a person has created a video and they've got 100 likes and 100 dislikes, I'm not very apt to go and copy the URL and show it to you. But like with a lot of these, they might have 5,000 likes and 50 dislikes. No matter how good you are, some people are always going to dislike it for whatever reason. They don't like your presentation, they don't like your style, they don't like your content, they hate your voice, it doesn't matter. So then after that, I went back and I said, well, some people would rather just have it hard copy. So you'll notice that the first 3 things that are in here are all from Visual Studio .com. So they're basically from the documentation for Visual Studio Code. The first one is a very generic one on just debugging. The next one is JavaScript in Visual Studio Code. And the next one, which ties into the second one, is browser debugging in VS Code. Then the other 2 articles, debugging JavaScript efficiently with Chrome DevTools. Again, we'll look a little bit at that in just a bit. And setting up JavaScript debugging in Visual Studio Code, an article in medium.com. I may have mentioned this to you before. I may not have. I don't remember. But there is a site that's called medium.com javascriptdebug.com. And basically, it's got articles in here that would help you for every single class that you're going to take here. In other words, there are JavaScript articles, there are Node.js articles, there are CSS articles, there are HTML articles, there are Android articles, really not too many C# articles, but I have seen some. Now, it ain't free. It's $5 a month. All right. When I first got it, my wife gets ticked because, every month with we get our MasterCard, I probably have $20 to $30 worth of charges. I'm taking an online course, or I'm doing this or whatever, and I'm like, okay, so I've got like $25 in charges. You've got $200 from TJ Maxx and a bunch of other places. And then she shuts up. Okay. So, but there's a lot of good articles in here. So, for instance, if I came in here and I just did a search on debugging JavaScript, for example, you'll notice that I'm going to get a bunch of different articles in here. All right? You don't have to go and sign up for it. I'm not pushing it. I don't get any money if you sign up for it. But sometimes people ask me for other resources over and above what you can find just by Googling something. Some of these articles they actually do put out there on the internet. Some of them are not. All right? Okay. In fact, usually in the morning I get an email from them every morning, and I pick out the ones I'm interested in, put them out here, and then I quickly look through them, and if I want them, I save them, and if I don't, I just get rid of them. All right. So, Chapter 5, we're on page 161, how to test and debug a JavaScript application. As you build a JavaScript app, you need to test it to make sure that it performs as expected. One thing I've tried to kind of impress upon you all semester, and that is I don't particularly care if how big the application is. You should write some code and then test it. If you've got a 200, even the apps that you were writing yesterday, the ones for the test. Now, the one that asked you to print out every number, odd number between 1 and 100, and the one that asked you to print out 15, 30, 45, 60, 75, and 90. No, there's so little code. But the other ones, you might have wanted to write a little bit, all right? So in other words, you might have wanted to write your interface if you were asked to create that label and the text box and the button. And then look at it, just bring it up. Then hook up your button with an event handler and then make sure that works. A lot of times I'll do that if I just want to make sure something works. Rather than putting the code in there, I'll just set it up so that if you click the button, I just get an alert that says button was clicked. Something like that, just to make sure the wiring is okay. And then go on and write a little code and check it, and then write a little bit more code and check it. Also, when you're doing that, it's a good idea to make sure that you're doing a save or a save all at all points while you're doing that. It's very rare today. When I was your age and I was doing this stuff, we were hooked up to a mid-range computer. So in other words, our machines were called dumb terminals. And we had a machine in there that was probably about as big as those 3 printers put together and about that high. But if you screwed up, you could get into an infinite loop or whatever, and you could not only bring your system down, if it was bad enough, you could bring down the whole mid-range computer, and everybody else's would go down too. So we were constantly told to save often. All right? So what do we have in here? Well, notice again, like I said, it's only about 15 to 20 pages long. First, we'll talk about the 3 types of errors that can occur when you create a program. You probably have seen at least some of these already. Now, with some of them, some of these errors are much easier to see in other languages than JavaScript because, again, JavaScript is a fairly forgiving language. All right? And we'll talk about some common JavaScript errors, and as it says, how to plan test runs. So, again, not looking at this, but let's suppose, because this is something that we still have to start writing up soon, I guess, as a class. And that is, I talked to you about that we would write up this program on creating a thing for body mass index. All right? So with body mass index, it's all based on your height and on your weight. So usually because I've set this up before, and we typically set up a minimum height of like 12 inches. Even a little baby that's born is usually 12 inches. Now, I know you can, well, what about, I don't care. All right, and usually I say that the biggest size, I'll make 96 inches. I don't know if there is anybody who's ever been 8 feet, but that should handle it. For weight, I usually make it between 1 pound and like 777 pounds. All right, because again, that should be big enough. The reason I'm telling you that is when you're testing, you definitely should test at a minimum for the height. You should test something that's out of range on both ends. So if it's 12 to 96, you should check 11, 11.99, and 96, 96.1, 97, etc. You should also make sure that 1 and 96 work as expected. Plus, you should do something similar with the weight. I'm not going to go through that. You get the idea. All right? Those would be what you'd put in for your test runs. It is almost impossible. I mean, when you think about it, okay, we've got what? If you go from 12 to 96, that's like 85 different heights. And if you go from 1 to 777, that's 777 different weights. I wouldn't expect you to test every single one of those. That'd be kind of foolish. You probably could put it in a loop and do that. All right, but even that, you typically that isn't what you're going to do. Now, there's different ways as you start coming in to test. I did want to show you this. You may or may not have been aware of this, but if I go into Visual Studio Code, don't worry about this. This is for the afternoon class, okay? But if I go into Visual Studio Code here, and I click on the extensions, and I type in JavaScript Debug, or just debug like that, it's going to pick up some stuff. So these are extensions that you can add. I'm not telling you to add any of these. All right? But, I mean, the PHP, that's a different language. But if I go here, JavaScript ES6 code snippets. So, you know, if there's typical things that you oftentimes use for JavaScript, you can add that extension. All right? And then I can come down to here. JavaScript Debugger, an extension for debugging Node.js programs in Chrome. You're not doing Node.js. That's what we do in the next class. But the point is, quite often when you look through here, there might be something. And if you're not sure if it's there and it's like this is a pain in the butt to look through, all right, then you might want to just go and Google JavaScript debugging tools available in VS Code. And some of that stuff is in those articles that I provided for you today. All right. So we will talk also about Chrome's developer tools. Okay? How to use breakpoints and step through your code. Well, you may or may not have been aware of this, but if I do come into Visual Studio Code, so if I come in right here and I go in here and let's see, this probably isn't going to work if I try to run it through live server, but I can try it anyway because this is a different language. So I have no idea if it'll work or not, but we'll try it anyway. Let's see. Do I have any? I don't even have a. I'll do this. Let's grab one of the other ones that we have. We got our pretest here. Oh, that's the other one. So this was the pretest that we did the other day. Okay, and I'm just going to bring up this one. You've seen this already, so again, 2, 3, 4, 5, 6, boom, we get that stuff. You already saw this stuff. All right, but the point is, if I come in right in here and I choose Inspect, we've looked at this a little bit, all right, but everything that you do using an alert is very temporary. I think you'd agree with that. Comes on the screen, you got to click a button. It's modal, meaning you can't go on until you click the button. Sometimes, at least, that's a pain in the butt to do. So everything that you've done so far using using an alert, we could have come in here and we could have come down to the console here and typed in console.log. So in other words, console.log, and we could have just put, I'm just going to put hello just so you see it. And boom, it'll put that there. So everything that we've done in here, in our, well, I thought I opened it, but in our Visual Studio Code, all right, we could have put, instead of putting alerts, we could have put in console.log statements. That's what I'm trying to tell you. Okay. All right, and again, there's other debugging methods. We'll talk about a few of those today. I went and looked online yesterday for JavaScript debugging exercises. Most of them, they don't suck. But the problem with most of them is they're written for advanced programmers. You know what I'm saying? They don't have a heck of a lot. Not only that, you may care, you may not, but if I go into our W3 schools and I type in JavaScript Debugging, all right, yeah, it does have something. Somewhere, there it is. And guess what? That's all of it. So it's one page. So they show you how you can use console.log, which is what I just showed you. All right? Now, when you are debugging, just so you know, and I just showed you this, so I just, come on, where are we? Showed you this. All right? Well, look at the difference if I type in console.error and I put in hello. Okay? You see how it comes back differently? This. It comes back in red. So what a lot of times what people will do is as you're debugging a program, if you've got an error section, you might use a console.error instead of a console.log, especially if you have a lot of them, because it gives you a chance to see what's going on. And if you expect some error code to be hit, you can print out values, etc. in there. All right. So, an introduction to testing and debugging. When you test an application, as it says, you're making sure the application works correctly, right? That makes sense. On the other hand, when you debug an application, you're fixing errors. So you test. The idea behind your tests, believe it or not, is to make all your programs fail. No, it's to make sure they're all written correctly, yeah. But you want to be able to test them and use enough different testing environments and different test cases that if it's going to break, you want it to break, especially if you're doing it for someone. All right? Tell you a very quick story. I don't even think you guys have heard this, but I'll try to make it real quick. All right? Years ago, I worked with a guy. He may not even be alive anymore. He was quite a bit older than me at that time, okay, about 30 years older than me. But his name's Ernie Gomez. Ernie's a great guy and did his job, came to work every day, did nothing but a good job, but never really got any credit. It was just like, yeah, that's Ernie, okay? And a guy that Ernie had worked with in his group who was working on another project, all right, he had an error in his code. This was telephony code, all right, back in the old days of, rotary phones, etc. And what happened was this error was not caught by anyone. So they cut this code over to a site in Ohio, and it immediately went down. So they flew the guy out there who had the error in his code. He fixed it. They flew him back that day, and they brought him into a meeting, and they gave him attaboys, which Ernie came to me. We were talking later one day in the lunchroom, and he's like, so he screwed up, and he gets rewarded for it. He said, personally, I think it's kind of a backwards mentality. So, and I probably shouldn't say this, and if you ever would see this, Ernie, I'm sorry, but what he did was he purposely put an error in his code the next time. It was very, very subliminal type of error. And the same kind of thing happened. And again, they flew him out, got him back, and he got congratulated for it. All right, and so he, basically what he said to me, not in these words, but pretty similar, were F up and move up. So in other words, when you screw up, you get recognized, and when you don't, you don't. All right? Well, you shouldn't be doing that. You should be testing your program and trying to come up with every test case you can possibly come up with so you break your code so you can fix it. When I worked for AT&T, what happened was I had to literally write what was called a design unit document, which described everything I was going to do, about 100 pages long. Then I had to write a test document. I hated those because they were about 500 pages long. I had to put every test in there I was going to run on a different page, the expected result, then I had to run the test and show the actual result. All right, and that's a lot of how I was graded, so to speak, for what I did. All right, so the idea was I was testing the application. When I found bugs, I had to fix them. I was debugging the application. Hopefully that, that made some sense. The three basic types of errors. All right, if we look at this, I'm going to just grab this line of code here, or this line that's in the book. It says, syntax errors violate the rules for coding JavaScript statements. All right, So if you can imagine, in fact, let's just say we took this whole paragraph here, right there. So we took that whole paragraph, and instead of having it in different sentences, we wrote it as one big sentence. That would probably be a problem. You know, I've used the example before, you know, you're in third grade or whatever, you start school, and the first day, for tomorrow class, I want you to write a one-page paper on what you did this summer. So little Johnny comes in and writes one page and it's all one sentence. I think the teacher isn't going to be happy. Why? Because he's violated the syntax of the language, which says what? We take letters and we form words. We take words and we form sentences. We take sentences, we form paragraphs. We take paragraphs, we form pages. We take pages, we form chapters. We take chapters, we form a book type of an idea. All right? Well, in much the same way, syntax errors are errors in the rules of the language. Now, just to show you one quickly, I just showed you this when I did this console.error, right? So I'm going to put it in again, but I'm in a hurry. Now, there's a bunch of errors in there. Like what? I spelled console wrong. I put a 9 in there at the end of error. And I don't have my beginning curly brace. So look where it found it. It's telling me there was a missing ending brace because it saw the beginning one, but since I put that double quote in there, it thinks this is part of a string. So it doesn't recognize the ending one. So let's just do this backwards. So I'm going to come in there, and this time I'll write it again, and I'll type in consoled, however I spelled it, something like that, dot error 9, and this time I will put that in as double quote, oops, parenthesis, double quote, hello, and hit enter. Now it's giving me a different thing. It says consoled is not defined. So I come back and I go to do it again. I can use my up arrow here. I forgot about that. So I've changed it from console to console and hit enter. And now it says error 9 is not a function. So I come up and I fix that. And boom, I get that. Now, I realize, well, that's kind of a waste. No, what I'm showing you is, first of all, when you debug, you should go from top to bottom. All right? It isn't that bad in this language, but I've used languages before where if you forget a period, for example, it can generate 100 errors in your program. And I'm not exaggerating. All right? And you should always debug from top to bottom. People don't like to do it. Well, that one looks like an easy error. I'll fix that one. It's nothing wrong with doing it that way, but a lot of times an error at the top will cause other errors to happen later on in your program. All right? So that was simple, but that was some examples of syntax errors. All right? So a runtime error occurs after the page has been loaded into the browser. Well, what's an example of a runtime error? What if I tell JavaScript that I want it to load this image and the image doesn't exist? All right? It doesn't know when it's running the program that the image doesn't exist. It only finds out that the image doesn't exist when you attempt to load the image. Does that make sense? All right. Now, one thing about JavaScript that's unlike, I think I can type console.clear here and it'll clear the console. If I type in here, for example, 34 divided by 0, notice it gives me infinity. Many other programming languages, rather than giving you infinity like that, it'll give you an error. You'll get like an attempt to divide by 0 exception. And if I even do 0 divided by 0, now it says NaN, not a number. Where again, that will break a lot of programs. This is one place where JavaScript is much nicer, so to speak, in its syntax because it's not blowing up right here. But there are certain errors that when the system doesn't know what you're trying to do is wrong. Let's say I said that I wanted to load a file, and I gave it the wrong path to the file. Well, until I attempt to run the program and load the file, the system has no way of knowing the path is wrong. but those would be runtime errors. So they're errors that occur when the program is actually running. All right? So now let's come in here and do the last type. So I'm going to say let x equal 10. Let y equal 15. Let sum equals x minus y. Say, hey, wait a minute, you didn't mean to do that. Let's see, equal x minus y. What does it like? Sum is, oh, I've already declared sum someplace. Okay, let the sum equal x minus y. And it says there undefined because I have to tell it to print. So if I type in here the sum and hit enter, it gives me minus 5. Wait a minute, I wanted to add those two, but I accidentally put a minus sign in there. That's a logic error. All right? Quite often, now that's a pretty simple logic error, but quite often they're the hardest ones to find. You're not programming very long when you get a sense of infallibility. Because I remember I had a student come up to me years ago and say, hey, I can't figure out what this error is. And I could see it right away. But I didn't want to do it like that and try to make them feel foolish. So I said, well, let's look through your code. I wanted them to find it. And they said, I don't see it. So I said, well, what about right there? Oh, geez, I didn't do that. Yeah, no, somebody else walked up to your computer, pushed you out of the way, put in a wrong line of code, and then walked away, right? Because people think they can't do things that are wrong. We all do. You're in a hurry. You don't totally understand something. It doesn't matter. All right? So they have this future value application with a logic error. Well, let's look at this. This says that if you invest $10,000 for 10 years at 3.5 a year, well, let's just say in the best case you double it, and it'd be $20,000. Okay? Well, I'm looking here, and it looks like it's $10,239,964.20. I want to go to that bank. All right? So it says, the goal of testing is to find all errors before you put something into production. The goal of debugging is to fix those errors. And we just went over what the three types are. All right? As it says, to test, you want to make sure that it works properly no matter what data you enter and what events you initiate. In fact, a lot of times what happens is if you were creating a program for a company and you think, I've debugged the hell out of it, there's no errors in here. They'll hook it up to a simulator. And if they will check every single possibility, have the computer do it. Somebody will write a program to do that. Like I said, with what we talked about before with 85 of this and 200 or whatever of that. All right, that's going to be too much for you to test. All right. In fact, it was 85, something like that, and 777. I don't know what that is, but I'm going to guess, just thinking about it, it's over 60,000. You're not going to test 60,000 cases. But you can write something, or the system can write a simulator to do something. Or somebody can write it. All right, so common JavaScript errors. It says figure 5.2 presents some coding errors that are commonly made as you write a JavaScript app. If you've been doing these exercises, you probably have made some of them yourselves. All right, now, it says if you're using a good text editor or an IDE, and one of the reasons we're using Visual Studio Code in here is it's a good IDE. The difference between an editor and an IDE, we're using an IDE, an integrated development environment. All right, not only does it give you things like color coding, you've seen all that kind of stuff, but it has extensions. It allows you to run your program right from there. All right. On the other hand, if we just used regular Notepad, that's an editor. All right. And actually the one that I've used sometimes in here, which has been this, which is Notepad++, is kind of in between an editor and an IDE. It has some, but not all IDE types of features. So, common errors. Some of these, again, you've already come up with. All right, misspelling keywords. I already showed you that with the console. All right, omitting required parentheses, quotation marks. I showed you those. Not matching up curly braces. All right, starting something with an open quote, with a quotation mark, single or double, and not ending it, or starting it with a single and attempting to end it with a double. Yeah. Yeah. Morning. Come on in. Just take a seat. All right. So, misspelling or incorrectly capitalizing an identifier. Remember, JavaScript is a case-sensitive language. So, in other words, looking at the example that we went over before, even the one that worked. So I've got let sum here, and I put the sum. So if I come through here and I say the sum, and I make it all lowercase and hit enter, all right, I guess that's what I did before. Let's put it all in upper. And I hit enter. This changed it because the console changed it. All right. But if I put in the sum and I put in two M's and I hit enter, it says it was not defined. That's a good debugging type of tool to have in there. All right. And some of that stuff you'll get with what we're working on. Some of it you won't. All right. All right. I've talked about this earlier, that you have to be very standardized as far as if you're going to use this kind of syntax, the camel case with sales tax there, then use that all the time. All right. If you're going to use what's called snake case, which is the second one, use that all the time. But be consistent. Just be cognizant of the fact that in some programming languages, you can't use the underscore. That's why I use camel casing with whatever I do, because I know that it'll work. It should work. I should be able to move it or port it over to any language. All right. Problems with data and comparisons. Well, one of the big things in here, we've talked about this already, is the use of the triple equals versus the double equals. Remember, the triple equals is identity and equality, where the double equals is just equality. So again, this should work, what I'm about to show you here. Hopefully it does. Oops, try it again. But if I come through here and I say, let x, maybe I don't have that, I'll say xx equal 23. Let yy equal double quote 23 double quote. All right? And I'll say if xx equal yy, and we'll just console.log they are equal type of an idea. All right? And then this. Notice it says they are equal. That's wrong. But since it's only testing the values themselves and not the type of values they are, that's why you get this. But on the other hand, if I say if xx equal yy, and we check it like that and put in our console.log, and we say, oops, they are equal, and we'll even put in here an else that says console.log they are not equal. Oops, oh, that was great. Well, I stupidly put a colon there instead of a semicolon, but what printout is they are not equal. Does that make sense to everybody? All right. All right. Floating point arithmetic, we've talked about this. Notice it says if you take this 74.95 and you multiply it by 0.1, you're not necessarily going to get 7.49 or 7.50. All right, because floating point math is imprecise. We've talked about this before. You can use the two fixed. Yeah, it'll help. Nothing is absolute in here. Problems with undeclared variables says if you don't use strict mode, this is one of the bad things, so to speak, about JavaScript. If you don't use strict mode and you assign a value to a variable that hasn't been declared, even if you stick it in the middle of a routine, JavaScript creates a new variable by that name and it makes it global. And it doesn't give you an error. all right? But if you put using strict at the top, remember that's in double quotes, bless you, using strict with a semicolon on the end. It takes some of the liberalness that JavaScript allows you to do, all right, and it makes it more conservative. All right. So as it says, when the engine in a browser comes to a JavaScript statement that it can't execute, it throws an exception. We will talk in a later chapter about exception handling. All right? And I've said this kind of thing before. If I'm walking down the street and I'm holding the hand of my 4-year-old granddaughter, Olivia, and somebody walks by and says, "What an exceptional child," I'll probably thank them, right? You know, unless they say, "What an exceptionally ugly child," or "an exceptionally stupid." They wouldn't typically say that, but you get the idea. On the other hand, in code, an exception's always a bad thing because it's an exception to the norm. It's something you don't want to have happen. All right? Okay. It says when you plan to test an application, you want to do it in 2 phases. In the first phase, you're going to test with valid data. Not only that, I would say you even break this up into a couple phases. First, you test it with valid data, but you test it with simple valid data, where in your mind, you don't even have to write a test thing out. You know, in the example that we went over before from the program, all right, when we just entered in the 5 values. Remember when I showed it yesterday, when I ran it for it, or 2 days ago in the pretest, I put in 1, 2, 3, 4, and 5 for our numbers, because it was easy to figure out the largest, the smallest, the average, the sum, etc. Then test it with more imprecise data. All right? Okay, so after you do that, you want to test it with invalid data. And you want to make sure that whatever results you're supposed to get, you get. Now, the good news is, with some of the stuff that you do, look at this program right here. You can tell that we've got 3 text boxes that aren't great. I think you'd all agree with that. So we could go into our HTML and we could take all 3 of those text boxes and say type equal number. That right away, that means the only thing that we can put in there that's non-numeric is nothing, blank. If we try to put any letter, any special character, it won't take it. Right? So we've handled some of that. But if we set it up and we put a min and a max in for number, and we say the total investment in there, let's just say we'll say the minimum is 1,000 and the maximum is 1,000,000. That means that you can still type, you know, when you do this and you click in here, you get one of those little up-down things that looks like this. All right? And you can do that and keep clicking on there, and it'll be only allow you to put in 1,000 to 1,000,000. But if you click in there yourself and enter a number, it'll still let you enter an invalid number in. All right? So what I'm telling you is, as you start to develop your test plan, there's certain things you can do to try to make it easier for you. All right? So by making all these numeric, we know that all we have to check for in there is blank. We should never, that's our is NaN check, basically, is blank. All right? And then we have to check, so we have to look, did we have constants in here? Do we have upper and lower limits? And we have to check those and make sure they're handled correctly. Then we have to go in and check, basically. So they're saying, first we want to check it with valid data. All right? Then we want to check it with invalid data. And I know that there's a lot of people who do it the other way. They do it with invalid data first, and then they check it with valid data. It's not that one way is right and the other way is wrong as far as the order in which you do it. I'm not going to sit and read to you, but you can take a look in here because it's pretty much what we just talked about. Look at the bottom. They do give you some problems with testing. Some people do that. They run one test case. Oh, it works. Oh, I also ran one test when it shouldn't work. It didn't work, so that's good. All right. You should test a wide variety of ranges. You should also, again, come up with a detailed test plan. Now, you're doing the test yesterday, and let's assume that we gave you 3 problems. And on that test, all 3 problems were fairly complex. You got 4 hours. You're probably not going to be able to have time to write a detailed test plan. So you know, what do? Well, on a piece of paper, I'm going to write down inputs, expected outputs, something like that. All right? All right, so then they get into how to use Chrome's developer tools. Some of this stuff we've already started looking at. Okay? Remember that when you're debugging your HTML, etc., that's not what we're talking about here. All right? So in other words, we looked at this a little bit earlier. That's the console, right? But we're not talking here about using some of the other stuff that's available in here. Okay? We're just talking about the console. The console basically is a JavaScript debugging tool. All right? You can go out online and you can find articles that will tell you that you shouldn't use this as a debugging tool. I disagree. There's nothing wrong. It shouldn't be necessarily your only debugging tool. But it's a great place to start. All right? So, you come in here and you start looking at the stuff that's in here. So I come in here and it's like, okay, I've started to go through this and there's problems someplace. All right? So, I mean, what the heck should I do? All right? Well, we already talked about this, how you can go in here and you can start doing different stuff. But there are a lot of different things that you can set up. I should just follow what's in the book instead of going off on my own tangent here. All right? So, to open the developer tools, you know how to do that. We've already done this. It says open the console panel by clicking on the console tab. We did that. All right? And if we had an error in our code, it should show us where that error is. Now, one thing about this, and we've talked about this kind of thing before. So let me go back to here and to here, and I'll just grab one of these. I'll grab one of the ones that was probably a little bit more difficult. I think 3, I'm not sure. All right? Now, you should know this already, that if I get rid of every semicolon that's in here, program will still run fine. All right? You should put semicolons in my humble opinion, but JavaScript does not require them. On the other hand, if I come through here and I've got 0 like this, and I attempt to use it in here, and instead of saying 0, I say 0, and I attempt to run the program, I'm going to get an error message. Does that make sense? All right, let's save this. And let's come back out here, and it was number 3. So there it is. Okay, oh, the input was not a number. Let's put in a 0 in there. Nothing happened. All right, yeah, something did happen, but you've got to right mouse click again and go to your inspect tool. All right, and I guess it's not showing it here, but at least sometimes it'll show an error right there. It depends on the severity of what you're trying to do, but this is a terrific way to start testing your program. All right. So it says how to find the error. Okay, and I don't know if it was in this class. I think it was in the afternoon class that I have. One of the students came up to me and she had this routine. It was 80 lines long. All right, and it said in here, hey, I've got this error and it's on line 78. No, it wasn't. That means the error is somewhere between line 1 and 78, but 78 was where it was found. She said, I don't get it because it's just a statement when I'm printing something out, and then I got a curly brace and a blank space afterwards. Yeah, it just means it's somewhere in there. So if you've got a routine that's 50 lines long and it says the problem's on line 13, that means it could be on 13, but if 13 is a blank line, it's somewhere between 1 and 12. In other words, it shouldn't be after where it flagged the error. It should be before. It's kind of what they're saying in here. All right? Now, when you do start running through your code and you bring it up in here, all right, so they've actually brought the file up in here. Notice, you may or may not have noticed, there's a little area that's over here. I think everybody can hopefully see what I'm doing here. I'm not talking about the numbers. I'm talking about the area, the white space, that's to the left of the numbers. That's called the gutter area. So if I knew that I was having an error someplace around line 29, I could click in that gutter area and it would make a, what is it, cyan, kind of a reddish brown circle. That would be a breakpoint, which meant the next time I ran that program, it would stop right there. It would break. All right, you got to kind of look at it that you're in one of three modes. When you're developing a program, you're in design mode. When you're running a program, you're in run mode, sometimes called execute mode. But if you put in a breakpoint, you're in break mode. So you're telling the system to stop running right there. All right, and if indeed that's what you want to do. All right, so rather than console, as it says, there is a sources tab in here. As we start looking through, I'm not sure where, mine looks a little funky right now, but it will be in there. There are sources right there. All right, so you can come through and you can start going in here. Yeah, it doesn't look like it. It's a drop a folder in, but notice there it is. So I can also go into my JS and, what was it, 3 I think we were, I'll just grab this one, it doesn't matter. All right, so we can come in there. And if I click over here, all right, that's going to set up a breakpoint right there. I guess maybe they changed it, maybe now it's bluish. All right, but it's told to stop right there. Now, there's certain things, and this should make sense to you. They have to be executable lines of code. You can't put a breakpoint in on a comment. That doesn't make any sense. You can't put in a breakpoint on a blank line of code. All right, so if there's nothing there. Now, this isn't really doing anything, but let's say that right here, so here's that while loop. So let's say I put a breakpoint in right there. The breakpoint stops the program before the line of code has run. Does that make sense? It breaks right there. So when it gets to line 29, it breaks. It does not execute line 29. If I wanted to execute line 29, and then I can put the breakpoint here. Notice I can put in multiple breakpoints. All right? But if I try to put one in here, notice I tried clicking here, and it won't take it because it's a blank line of code. All right? All right. Now, when you start to go through your code, here's a couple things. You won't remember these. And maybe I'm wrong, but the guys back here who were in the class last semester, it works very similar. They were using Visual Studio as opposed to Visual Studio Code. All right. That said, they work pretty much the same way. They're your function keys at the top of the program. So F11, kind of a neat thing to do because it runs through your program a line at a time. So it runs through a line, it's got to be an executable line, then it stops, then you hit F11 again, it does the next executable line. All right? Sometimes that's very helpful. All right, next, F10, run any called functions without stepping through them. So if you've got a function that's 20 lines, basically it calls it, then it returns. It doesn't go through a line at a time, is what we're saying. Then there's a step out, which says if you're in the middle of a function and you don't want to run it anymore, think about this. What if I was looping from 1 to 1,000? And I got into there and I'm like, geez, you know what? I've done this 30 times already. I got 970 to go. You'd probably want to step back out of it then. Then there's a resume, and the resume says, hey, even if I got breakpoints, just blow past them and just run the program. All right, so those are the different things that we can do. Again, some of this I already mentioned. You can set a breakpoint on any line except a blank line or a comment line. I don't think it'll take either. At least it used to not. A light blue arrow around the line number marks the breakpoint. All right. Other debugging methods, and some of these we've talked about. You know now what log is. You know you log to the console. So there's a console.log for regular statements. There's a console.error. We've talked about both of those already. All right? Many people, many books today, if you look through them, are not even talking, they're not even teaching you the alert anymore in JavaScript. Because they're saying that's a pain in the butt. It just slows down programming progress. Because you got to stop because it's modal. Because you have to stop and answer it. They tell you when you're running your program, have a Chrome developers window open and go into DevTools and have your console open and do console.logs. All right? So they show an example here. This was that one. So again, $10,000. All right. 3.5 percent interest, 10 years, and it says your future value. That doesn't sound bad. All right? But it's showing you in here every time you go through. It's a good way to learn, too. And it's also, if you've got, for instance, one of the programs that I've given in the past was basically you had to figure out like a mortgage calculator. And that wasn't too tough. People typically got it and did pretty well on it. Well, then it got harder. Because then you had to start figuring out, okay, for each payment you make, how much is going to interest and how much is going to principal. If you don't know anything about houses, you know, your first several years of the house, you're paying all interest almost, and very little principal. Then towards the end, you're paying almost no interest and almost all principal. All right? But there's a formula that you have to use to do that. And one way that you can, you know, it's one thing that you can do is step through it to make sure that the stuff looks like it's working the way it should be. All right. And that's pretty much what they explain in here also. They do say the alert, but again, it says they're intrusive. In other words, it can be a pain in the butt to use. There's other methods. All right. It says you can also use in Chrome's developer tools, there's something that's called a stack trace. All right, so what's a stack trace? It goes through a list of every routine that's been called, from the last one that was called to the one before that, to the one before that, to the one before that. All right, and what happens when you run this then is you get what's called a stack trace. And sometimes when it shows a stack trace, depending on the language, if you are calling functions that aren't yours, that belong to the language, it shows you all of them. You know, I always tell people this, and you'll see this, you guys will see this next semester in the Android class, that when we have a stack trace, sometimes called a stack backtrace, but a stack trace, and you look at it, if there's 15 functions and 10 of them aren't yours, guess what? The errors are not in the ones that aren't yours. The errors are in one of your functions. You called something incorrectly or did something incorrectly. The functions that make up the API, the application program interface, of that particular thing, they're not going to be called into question. All right. All right, so there's a lot of different methods that you can use, in other words. All right, how do you view the HTML and CSS? Well, a lot of this you already know. All right. So again, they're talking about the other things that you can go in and do to check your HTML, all right, and or to check your CSS. And again, we've already gone through these in the HTML, CSS portion of the class. So that's it. All right? So literally, I didn't provide any exercises for today. But, you know, one thing that I would like to do, well, maybe we'll do this towards the end of the period today. We still have not gone over the written tests for chapters 2, 3, and, or what is it, 2, 3, and 4, I guess. All right, so we'll do that by around the end of the period today. Okay? The rest of the period then will be lab. Questions? All right, and then going back, just so you know this, again, tomorrow, you've already seen this. This is how we started class today. But so today we did the lecture on Chapter 5. So the labs and the homework are already in your stuff, so just keep working on those. I believe for 5, either the homework or the labs, there aren't any. And for the other homework or lab, whichever one it is, there's one problem. They give you a buggy program, and you have to fix it. I have not looked yet at the test Mr. Smith has written for chapters 5, 6, and 7. My guess is there'll be nothing from 5 on there because you have to understand basic debugging skills from the get-go period. Does that make sense? All right. But anything that's in there for homework or labs is due Friday the 22nd. So tomorrow, we'll go over Chapter 6, all right? And for Chapter 6, come on, it's how to script the DOM with JavaScript. Like I said, I would, if you get time, I would at least page through that. It's a longer chapter than this one. It's almost 40 pages. This one was less than 20, or around 20, all right? And then on Friday, or Thursday, I guess Wednesday, Thursday, Friday, we will go through Chapter 7, which is how to work with images and timers. Timers especially are kind of cool because it'll allow me to give you a lead-in to what you'll have for the advanced JavaScript class that you take in the 3rd semester. All right? Okay. I asked if there were any questions. You said there weren't any. Remember, so 5, 6, and 7 over the next 3 days. Lab next week Monday. Lab next week Tuesday. All right, I think that's what we said. And Wednesday, I believe, of next week then will be our pretest. Thursday will be our test. Friday will be a lab. All right, that will get us to the 15th. And I even notice this. All right. And we're going to be going over 8, 9, 11, and 12. I guess that'd be 10 to 12 probably. But that's the jQuery stuff. There'll be no homework on the jQuery. There'll be no written tests. There'll be no labs. There'll be no tests on that. I'm going through that for completeness. Over 2 days, it'll probably take a good hour for each one of those, maybe a little bit more, and then you're going to have lab the rest of the week. Then, for lack of better words, we hit the hard stuff. It's the more advanced stuff that's in here at the end of the book. All right? Okay, that's all I got then.